Nano. This word has common usage in our daily life. We see many products in the market in the name nano in one way or other. To mention a few, we can see nanomaterial coated fabric, nano silver coated clinical plasters, nanoparticle coated floor tiles, and so on. So everybody has a curiosity to know what is nano and why nano. Is it safe to use nano? So many questions arise in our mind. Let us have a look into the nano from the basics and try to find answers for our questions. Let us start from a larger scale, which we can visualize, say 1 meter. This is how big it is. Now, if you see the increasing order, this is a road and you might have seen milestones marked in kilometers, that is 10 power 3 meters. Now we go still higher. We can say the area of India is in kilometers squared. And of course, the diameter of the sun is 10 power 9 meters. We say it is measured in gigameters. Now coming to lower dimensions. Peace is of the order of millimeters, that is 10 power minus 3 meters. A RBC cell has a dimension of micrometers, that is 10 power minus 6 meter, and a virus has the diameter of 10 power minus 8 meters, and a cholesterol molecule which gets deposited in the arteries of our heart has the dimension of 10 power minus 9 meter, which we call as 1 nanometer. It is predicted that in the time you read this sentence, your nail would have grown 1 nanometer. There are some examples of naturally produced nanoparticles which we see in our daily life. The one cooking fume coming out from firewood stoves, vehicle exhaust pipes, welding. The most important one is the composition of our bone, which mainly consists of nanoparticles in a structured form, usually referred to as nanostructures. To understand, let us see some of the basics which we would have studied in our school times. We all know an atom. It has a nucleus in its center and surrounded by electrons. Let us see only its dimensions, that is the diameter of an atom. And we see that it is around 10 power minus 10 meters, which we call as 1 angstrom. And this is 10 times smaller than a nanometer. This means that normally 10 atoms can be present in 1 nanometer. So we can say that 1 nanometer contains 10 atoms. 10 nanometer contains 100 atoms. And similarly, we can go on adding up. But if you take a bulk material, it will contain billion atoms in it. For example, if you take hydrogen, it is calculated that there are 10 billion atoms in 1 centimeter. We all know 1 billion is 10,000 lakhs. Therefore, 10 billion will be 1 lakh atoms. So because of this confinement in a smaller volume, the properties of nanomaterial differs from its bulk material. Now we can take two examples in bulk. One is aluminium and another one is gold. When we convert this into nano form, that is nano aluminum and nano gold, we see the difference. Nano aluminum becomes an explosive, whereas nano gold has totally different property, that especially its color. Is nano created by scientists? You are seeing two images. One is the image of an Indian king's courtyard, and another one is that of a church in Rome. These are constructed more than 200 years back, when the concept of nano or paints are not known. But till today they are beautiful with a lot of colors on it. How this is possible? With the help of advanced technology, now we have found that these paintings are made using nanomaterials. Now here you see the electron microscope images of silver and gold nanoparticles. The size, shape are very important in nanoscale. As we change the size and shape, the color changes. This is a wonder which our ancestors have explored centuries back and have well understood without knowing it is a nanomaterial. Is nano a man-made one? No, it was already in nature. You see the surface of a beetle, a peacock feather, a lotus leaf. These are all very good examples of nanomaterials inside. Peacock feather tells you stories about nano dimensions. It is discovered now that peacock feather is a composition of zinc sulfide nanoparticle. Using electron microscope, if you see the close look of the peacock feather, it will appear like this. Now, if we magnify further a portion of it, you will get this image. You can see that a lot of parallel lines on it. Further magnification, we see uniform structures inside it. You see the wonders of God's creation. Now engineers have identified that these structures have huge surface area and have replicated it as heat transfer elements in vehicle radiators. Now take a lotus leaf. We all know that water will not stick on to this upper side of the leaf, and on contrary, the lower surface is always in contact with water. This is a different situation. Same leaf, upper surface is water repellent and lower surface is water attractive. We call this upper surface technically as hydrophobic, meaning water repellent, and the lower surface as hydrophilic, meaning water liking. Now you can see the electron microscope images of upper and lower sides of the lotus leaf. We note that the configuration is totally different on the upper side and as well as on the lower side. Now once again we see the wonders of God's creation. Now we see the science behind all these nanomaterials. Two parameters are normally involved. One is the surface and the other one is the surface area. These two parameters play a key role in differentiating nanomaterials from other materials. Let us see one by one. First, let us take a simple school problem on surface area. Consider a cube of length, say 4 centimeters. Then you know the surface area is equal to 96 centimeters squared. Then, now we cut the cubes into two halves, both laterally and vertically. Now we get 8 small cubes, each of length 2 centimeters. Now, if we calculate the surface area of the cubes, now we get that is equal to 24 centimeters squared for one cube. And of the total 8 cubes, it comes around 192 centimeters squared. So what it shows, if we reduce the dimension of the bulk into smaller dimensions, then the surface area increases. From this, we get an idea on surface to volume ratio. As we know, surface area of a cube is 6a squared. Volume of a cube is a cube. Then surface area to volume ratio will be 6 by a. Now come to the problem. If a is equal to 1 centimeter, that is 10 power minus 2 meters, then my surface area by volume will be 600 meter. Now if I reduce that a to 1 nanometer, now my answer will be 6 into 10 power 9 meters, which is a huge number. Imagine 9 zeros coming after 6. And this is the beauty of the surface area in the case of when we go to the nanoscale. So what is the use of it? Or what its implication? As the surface area to volume increases, the ratio increases, reactivity is high. A simple example is of putting a sugar cube and sugar crystals in a cup of coffee. Which dissolves first, sugar cubes or crystals? It is very clear that the sugar crystals will dissolve first because the surface area to volume ratio of sugar crystals are more, and hence the reactivity is high. Take a look at this comparison. A cube with 1 centimeter length gives 6 centimeters squared as surface area. The same cube, if divided into small cubes of 1 millimeter length, the surface area increases to 60 centimeters squared. And if the same cube is further divided into nano-sized cubes of 1 nanometer length, then the surface area becomes 60,000 centimeters squared. And if you convert that into meters squared, you will get 6,000 meters squared. So that is the very important thing. We start from a 1 centimeter length cube and we get a surface area of 6 centimeters squared. And finally, we are divide that 1 centimeter cube into small cubes, and with each cube having 1 nanometer dimension, we have reached a point where it is 6 into 10 power 3 meters squared. This is how the dimension becomes very large. So for a comparison, we can take a tennis court whose dimensions are given. The area comes around 195.62 meters squared. So for calculation, let us approximate to be it is to 200 meters squared. Now compare the surface area of the tennis court with the previous calculation of a cube having 1 nanometer small cubes. You can compare, that is 6,000 meters squared, this is 200 meters squared, and what we have understood, the surface area of the cube with 1 centimeter length, which is divided into 1 nanometer small cubes, is equal to 30 times the surface area of the tennis court. Imagine how a small quantity of material is able to create such huge surface area. So this is the wonder in the case of nanomaterials, and that is why it is finding wide applications anywhere, and also it is very important in miniaturization of equipments. Now take the surfaces. As I have already told that there are two types of surfaces. One is a hydrophobic surface and another one is a hydrophilic surface. Normally, this is determined by measuring the contact angle of water droplet on the surface. If the contact angle is less than 90 degree, then we call it as a hydrophilic surface. And if it is more than 90 degree, it is a hydrophobic surface. And if it is more than 150 degree, we say it is a super hydrophobic surfaces. Scientists have created many nanocomposite based water repellent surfaces by mimicking the lotus leaf, and they have found wide applications in many of the industries as well as household materials. Now you see a picture of a rocket. The rocket is put in the launching pad, and a rocket will be put up in the launching pad some about 10 days before the actual launch, and they will start the countdown, and they will check all the parameters whether everything is correct. So this rocket, which is being put up in the launch pad, will be exposed to different climatic conditions. Say sometimes a day there will be a heavy rain, so like that it will be exposed to different climatic conditions. Now the scientists would have calculated the payload and everything, the amount of fuel to be given to the rocket, everything they have calculated. Suppose if the surface is absorbing, suppose we take it is a heavy rain is going on, and the surface is started absorbing the water that is falling on it, then all these calculations become wrong. So what we need is we have to coat the entire rocket with a super hydrophobic material so that not a single drop of water is absorbed by the surface. Therefore, in a rocket, always a nanomaterial based hydrophobic paints are coated on the surface. Now we have seen water repellent fabrics and floor tiles are available in the market, and they are also applicable. They are also using such type of hydrophobic materials for coating. These are possible due to nanomaterials. Now you see nano silver, one of the very important material and widely studied material is nano silver. Nano silver has been explored in many medical applications. They are more effective in killing bacteria than other antibacterial drugs. This has been proven. So many products have come up with nano silver coatings, and a lot of products are now available in the market, and we have shown few of here. The antibacterial property makes it widely applicable in many products so that the contamination can be completely eliminated. Though there are many wonders that the nanomaterials have made in science, there are few things to worry about also. The main thing is its dimension, that is the nanoscale. When it comes to technology, it has risks as well as benefits that everybody know. Now you see an image. This image is an electron microscope magnified image of the sweat pore on our skin. You can see the pore diameter is little larger than the nanoscale. So a researcher who is working on nanomaterials must take much precaution so that nanomaterials do not enter his body through such pores. So this should be very careful for researchers who are handling nanomaterials should take precautions. They should cover their nose, mouth, and hands should have gloves, everything. Proper precaution should be taken. But once it is made as a composite or it is coated on surfaces, then there is no problem or no worry of it getting into your body. So the products when come to our doorsteps, there is no problem because it is completely coated and all proper precautionary measures have been taken. So the precaution has to be taken by the researchers only. And we know all technology has its own risk, whether it is a nuclear plant or a transportation of a petroleum product in lorries from one place to another places. And you know petrol is highly inflammable. So always proper precautions and training must be taken before handling such technology based, and nanotechnology also needs such precautions. Thank you very much for watching this video.